As mentioned the other day, we're now going to look at these specific process devices, the NOT, the AND and the OR. These are also called logic gates, and they will take an input, process the information about that input and give us the desired output depending on the situation we want to solve. Now, just to very briefly go through them, you've got NOT, AND and OR, and they all do different jobs. Now, specifically, you need to be aware that the NOT gate only has one input. The AND gate, it has two and it needs two. Same with the OR gate, it has two inputs and you have to always attach two inputs. So the NOT gates only get one input, AND gates get two, OR gates get two. They all, however, only have one output, because whatever problem we want them to solve, we want one answer. Now I'm going to use the buzzer again for my permanent output device, because it's nice and loud, it's easy to hear. Right, so I've connected the NOT gate to the buzzer. Now the NOT gate's name tells you the job it's going to do. Now, up the top, I've got a slide switch, just your general run-of-the-mill up-down switch. And at the moment, when I switch on my power supply, oops, a daisy, I'll disconnect the buzzer for the moment. At the moment, the switch is on. You can see the LED, I've covered up the LDR, takes that LED out. The LED for the light switch is on. So as I've mentioned in the past, that's an input of 1. Now, what you can probably already see is I will input my 1 into the NOT gate, and you will see that its output LED has gone off. I'll connect the buzzer back. So when my switch is on, I get no output. When my switch is off, I get an output. Now the easy way to remember how a NOT gate works is it does what's not asked. So I've put an input in, but I'm not getting an output. I don't put an input, and I do get an output. So whatever the input is, the output from a NOT gate is the opposite. So now I'm going to move down and look at the AND gate to see what requirements are needed for it to work. Now the AND gate's got two inputs, so I'm going to use both inputs, but I'm going to use the switches. So it's easier to control both the switches. Right, so here we go. This is just a general slide switch. This is a push switch. So if I don't push it, I don't have an input. If I do push it, I do get an input. Right, so at the moment, as I was saying, this AND gate requires two inputs. Input A and input B. And at the moment, both A and B are 0, and the output is 0. Let's say, for example, I make input A a 1. So now I've got A is 1, B is 0, the output is still 0. Sorry, wrong one. So what if I make the top one 0 and the bottom one 1? The output again, still 0. If I make them the only other combinations, so I've done 0, 0, off, 0, 1, off, 1, 0, off, 1, 1, on. Loud. Now the AND gate, I will do truth tables with the class at a different time, but the AND gate will only give you an output if both inputs A and B are 1. Now I'm going to move down to the OR gate, and we're okay for the moment. Still using the same two switches, still thinking about the same 0s and 1s. So switch A is 0 and switch B is 0. We have no output. If I make just slide switch A a 1, you will have noticed I didn't move the output. Right, so start again. Slide switch A, 0, slide switch B, 0, 0 output. I change one of the switches, I get an output. I do the same for the other switch, I get an output. So quite clearly, if I do both switches, I also get an output. And the way the OR gate is best described is you will get an output if either A or B or both are 1. So the only way you will not get an output from an OR gate is if A and B are both 0.